Hi guys, now in last class we have studied about absolute error. In this class we will study about mean absolute error, fractional error and percentage error. Okay, so see mean absolute error. This is the mean value of modulus of absolute error called mean absolute error. Alright, so in last class we have studied about absolute error and that was delta x1, delta x2, delta x3, delta x4 and to be continued. So like that, there we have seen that absolute error was, and that would be positive, negative and 0. So here we have to take its modulus. That means only positive part we have to take. So whatever is negative, whenever you will take its modulus, so that will be converted into positive part. Okay, that's why here we have taken modulus of absolute error. See here, there is modulus of absolute error. So for that one, therefore mean absolute error, this one is represented by like that del x mean. So this one is, you have to take absolute error. So your absolute error is delta x1, but you have to take its modulus and then you have to find mean value. So plus delta x2 plus delta x3 plus up to whatever. So up to suppose you have n number of absolute error, so that is up to delta xn, and because you have n number of absolute errors, that's why it is divided by n. Then from here you will get your mean absolute error. So this one is the way by which you can find the mean absolute error. And see one thing, that your mean absolute error is completely positive part. There is no negative. Okay, so a note will be there. Accordingly, just write down a note that the mean absolute error be always positive. Okay, and now then the next one is fractional error. Fractional error, actually fractional error is also called relative error. So this one is also called relative error. Relative error. Alright. So it is very simple. Actually, it is the ratio of mean absolute error to the mean value. Because we have taken in absolute error, there are one number of measurements. So to find absolute error, we have taken first of all mean value. So that mean value we required to find the fractional error. So actually fractional error is also called relative error. So here you can write down in short that 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 it is the ratio of mean absolute error to the mean value. So in short, if fractional error is represented by Fe, so this Fe is equal to, it's very simple, that mean absolute error. So we just write down here that mean absolute error to the mean value. And you know that mean absolute error, just del x mean, this one is del x mean, this one is your mean absolute error, and there is mean value. So a mean, x mean, so there will be x mean, xm. Alright, so this one is your result. Now accordingly you have to find percentage error. Okay, so for percentage error, this one is very simple. Percentage error it is the product of fractional error with 100. It is very simple. So if percentage error be represented by like this, therefore just write down that percentage error is equal to the ratio, the product of fractional error with multiple of fractional error with 100. So simply write down Fe into 100. Be just like an example, a question be there that find the percentage error of the measurements are 1.1 meter, 1.12 meter and 1.31 meter. Respectively. So here you are seeing in this example that you have to find the percentage error of the measurements, and these measurements are 1.1 meter, 1.12 meter and 1.31 meter are there, and then we have to find the percentage error. So how you can find? Then first of all you need to find mean value, then mean absolute error, then mean absolute error, then fractional error, then you are able to find your percentage error. So it is a long process, but right now you see here that how you can find it. So first of all, you need to find your mean value. So in this solution, so here you are seeing you have given the measurement. So you have measurements x1, x2, x3. So x1 is how much? 1.1 meter. How much be x2? 1.12 meter. And then x3 be 1.31 meter. So you have, these are the measurements. Alright, these are the measurements. Now from here, you simply find out first of all its mean value. So the mean value of the measurements. So your mean value be xm or x mean, you can write down for you. So this one is how much? x1 plus x2 plus x3, because you have 3 measurements only. That's why it is divided by 3. And then put the value. Then you will get your x mean. So your x mean, that will be 1.1 meter. First one is, second one is 1.12, and your third one is 1.31. All these are in meters divided by 3. So you just write down your meter, and then you find its mean. So first of all, you take its sum. So 2, 1, 3, 3 and 1, 4 and 1, 5, and 1, 1, 1, there is 3, and then divided by 3. After being division, your x mean, that would be 3 1s are 3. Now 3 1 3 3 3 3 3 17 21, and then 6, and then again 6 6 6 6 be there. So you just take 1.176 meter. You just take it equation 1. Okay, and then you just find its absolute value. Okay, so absolute error. Then in next step you need to find absolute error. So absolute errors. Alright, so how much we have absolute errors you can find from here. So there will be 3 absolute errors be there, that is del x1, del x2, del x3. These are your absolute errors. So from here, your absolute error is the difference of mean value to its indivisible measurement. So this one is your mean value minus indivisible measurement. You get it from here. Alright. So mean value minus indivisible measurement. So this one is x1, x2 and x3. Now put the value. So how much be there? Just put the value. So your xn is how much? 1.176. So whenever you will subtract 1.1 from here, so how much you will get? Just to subtract from here, so you will get 0.076. So that would be 0.076. Alright. Okay. This one also is in meter. Okay. Okay. Now, in second one, xn is 1.176, then you have to subtract, the second one is 1.12. So you just subtract from here 1.12, so you will get 0.056. So this one is 0.056 meter. And now, after doing calculation of third one, that you have to subtract 1.31 from your x mean. So 1.31 you have to subtract. So because see 1.21 is greater than 1.176. So you just subtract and just do here that I am subtracting 1.31 from 1.71. I am going to subtract 1.76. So how much be there? See, there is 4, now 10, 3, and now 2 1 1 1, and that is 0. Once check once again, there is 4 3 2 1. So see here, 0.134. Okay, so this one is with negative sign, 0.134 meter. This one is negative. Negative stands for that there is a fault in your measurement. Negative sign doesn't mean that your subtraction is to be negative. No. This means that whatever your mean value, you suppose you're going to measure 1 meter, next time you just going to measure 1 meter, but that becomes 1 meter 1 centimeter. But in third time whenever you going to measure, so that becomes not absolute 1 meter and 1.1 meter, that becomes 99 centimeter. That means there is a negative sign. So negative sign represents this one only. Okay, alright. So this one is minus 0.134 meter. So you got your absolute error. See, here is absolute error and this one is your mean value. So you need it actually. Okay. So what I am going to do in next step, just remove it from here and just you remember only this one. Equation 1 and your this equation. So you just suppose that this one is your second equation. Then you have to find mean absolute error. So you just find out this one, that mean absolute error. Here I am just directly going to be find. So there is mean absolute error that you have to find. So there is mean absolute error. Alright. So how you can find this one, mean absolute error? It's very simple, that your del x mean, you have to take the modulus of absolute error, that is mod of, that means there is a positive part you have to take for everyone, but simply you just write down accordingly, that is 0.076 plus how much be there, yeah, there is second one is 0.056, and now the third one is how much be, yeah, there is negative one with there, that 0.134, and we have taken all of these in its modulus. So we have 3 number of absolute error. So this one is divided by 3 because I am just going to be take mean value. Okay, so this is called mean absolute error. That's why del x mean, and you just take it sum. So just take here 4, 6, 10 and 16. 1 be there, 3, 1, 4, 5, 9 and 7, 16. Again 1 be there. So 1, 1, 2, 2, 2, nothing be there. And yeah, 0. Then divided by 3. After being calculation from here, you will get how much be there, 0. You just take it from here, that 3 8s are 24. Alright, so 0 and 8. Okay, and then again you're just getting 2 and 6, so again 3 8s are 24. Again 3 6 are 18, 6 6 6 6 6. So I'm just taking here 0 6 6. You just take 7 like that. Okay, and yeah, this one is also in meter, and this one is your next equation, third degree, equation third. Then you have to find, you have got your mean absolute error, then you need to find mean absolute error, fractional error you need it. Okay, so you just find fractional error and just remove this one. In fractional error we use this equation 1. So just you just find out fractional error, fractional error. So how you can find this one? This is very simple. We have studied right now. Yeah, fractional error is the ratio of mean absolute error, del x mean, divided by mean value, that is x mean. Now for the value, your del x mean from here, equation 3, 0.0887, and this one is divided by mean value, that is 1.176. Okay, that would be 0.0754, and this one is your next equation, just see equation 4. Now we have used this equation and then we have to find percentage error. So it is very simple, we have to find percentage error. So percentage error, just like I am just denoting it like this one, that percentage error. So percentage error be just like fractional error multiplied by 100. So from here we will take fractional error from here 0.0754 and multiplied by 100. So how much will there? You see just multiplied by 100, so that will be 7.54%, and this is our answer. So this is our answer.